Hey, welcome back guys. Happy Wednesday. So our video for today, we're going to build on top of what we did yesterday, and we're going to keep talking about the mole. Remember that the mole is a really important unit in chemistry. It's like a bridge. It helps us connect from the microscopic world to the macroscopic world. So let's take a look at what I have on the whiteboard here today. Just a little bit of review from yesterday. Remember that we talked about Avogadro's number. And Avogadro's number, sometimes we can shorten it to NA, number Avogadro. This is the number of things in 1 mole. Just like there's 12 things in a dozen, there's Avogadro's number of things in a mole. And that number is 6.022 times 10 to the 23rd power. And then I actually wrote out Avogadro's number today, so you can see just how big that really is, 10 to the 23rd power here. It's a huge number, 602 hexillion, a very, very big number. But that's good, because we're counting very small things, like atoms or molecules. These particles are so small that we have to count them in supermassive amounts to make them meaningful. If I only had 5 atoms of something, that's truly insignificant. You've got to have billions and billions of atoms or molecules to start being worthwhile to count. So Avogadro's number, we can shorten it into scientific notation. We can shorten it even further into this abbreviation here. And remember, the way that we apply it is going back and forth between particles and moles. So for example, 1 mole of carbon is the same as Avogadro's number of atoms of carbon. 1 mole of carbon is this many atoms of carbon. It's just like if I said 1 dozen of carbon would be 12 atoms of carbon. 1 mole of carbon is Avogadro's number of atoms of carbon. We're going to take that one step further today, talking about this new word, molar mass. Molar comes from the word mole, the molar mass. This is the mass of 1 mole of substance. Just like it says here, molar mass. It's the mass of 1 mole of substance. Every substance has a unique molar mass. For example, carbon's molar mass is about 12 grams. Now, hopefully that number sounds familiar. 12 for carbon. It's the same number that we're going to find on the periodic table for the atomic mass, or the average atomic mass of carbon. This is another way that we can use the periodic table. It's very helpful for us. The average atomic mass that's on the periodic table, that is measured in atomic mass units, which are very small units used to measure the mass of atoms. But we can take that number and we can kind of scale it up. And instead of measuring in atomic mass units, we can say that the molar mass is 12 grams. The atomic mass, 12 AMUs. The molar mass, 12 grams. It helps us go from a very, very small measurement, atomic mass units, to something that we could visualize or that we could actually measure with a balance, grams. We have equipment that will measure in grams. And then down in blue here, I've got one more example. This is propane. We've talked about propane a few times in class, C3H8. If I wanted to figure out the molar mass of propane, I would take the mass of carbon and the mass of hydrogen and multiply it by the subscripts. So I'm going to find the average mass of carbon and the average mass of hydrogen and multiply them by these subscripts here. So the average atomic mass of carbon is 12, like we said. So I could do 3 times 12. The average atomic mass of hydrogen is just about 1, so I did 8 times 1. I add these terms together, and you can see I got two different answers there. On top here, I put 44 AMUs, 44 atomic mass units. That's actually the molecular mass of propane. One molecule of propane is 44 atomic mass units. 1 mole of propane is 44 grams. That's why we can say 44 grams per mole. For every mole, it'll have a mass of 44 grams. So hopefully you're seeing that this is familiar. This is a skill that I've already taught you, finding the molecular mass. We're changing the unit now, and we're going to call it the molar mass. I was kind of thinking ahead here, already getting you practice with that molecular mass, so that it would be easier when we got to this point. So one more time, a quick recap. 44 atomic mass units, that is the mass of one individual molecule. One teeny tiny particle of propane. But if I had a bunch of propane, if I had 1 mole of propane, this many particles of propane, then it would be 44 grams. 44 grams per mole. We call that the molar mass. So I'm going to go ahead and erase this whiteboard, and in the next little clip here, we're going to take a look at how can we take this molar mass and apply that to some dimensional analysis. How can we actually use that molar mass in a story problem or in a word problem? Let's do that next. Alright, so let's see if we can't solve a story problem using this concept of the molar mass. So we're gonna, hello Lua, excuse me, I'm doing a lesson right now, excuse me. So we're going to take a look at the whiteboard, and we'll see if we can work out this problem here. So the problem says, what is the mass of 5 moles of sulfur? And then I even gave us a little element block of sulfur here. I still want to approach this much the same way. I'm going to use my story problem skills, follow the question word. What? What is the mass? So if the question is asking, what is the mass? When I'm doing dimensional analysis, that tells me that I want to start with a mass unit in the numerator. Grams is going to be my mass unit. So if I'm starting from grams, but the only information that the problem gives me is moles, I need to find a way to go from grams to moles. This is like the molar mass, grams per mole. We saw that unit on the last little segment too. So looking at these units, grams per mole, it's the molar mass. The molar mass of what? I'm looking for the molar mass of this element here, sulfur. It's gonna match the average atomic mass, which is 32.06 atomic mass units. The difference is the scale. The average atomic mass is the mass of one atom. The molar mass is the mass of 602 hexillion atoms, a mole of sulfur. So I'm going to take this number, 32.06. There are 32.06 grams in 1 mole of sulfur. So you can get this number straight from the periodic table. You want to change the units to make sure that you're on the macroscopic scale and not the microscopic scale. But finding this molar mass is really not too bad. I just looked it up. My problem's not done yet. I still have not used these 5 moles. So I'm going to start a new fraction here. I'll take this unit in the denominator and I'll carry it up. And now I'm going to look for something in my story problem that has moles in it. And that's that 5 moles over here, 5.0 moles. So looking at my problem, I know that this is the molar mass, the mass for 1 mole, but I actually have 5 moles. So I'm going to take this molar mass and I'm going to multiply it by 5. These units would cancel out. And if I do this, some real quick math here, what is that, about 140.3? About 140.3 grams of sulfur in 5 moles of sulfur. So this is really nice for us. We can actually measure out 140 grams of sulfur if we had a balance or a scale. But counting all the individual atoms of sulfur to get up to 5 moles, that would take 10 lifetimes. It would not be doable by a human. So instead, we work out this math so that we can take something on a microscopic scale, like little tiny atoms of sulfur, and we can bring it up to something more reasonable on the macroscopic scale, 140.3 grams of sulfur. That's something we would be able to see with our eyes, we could measure it with equipment, and we wouldn't have to count individual atoms. I'm going to change this problem just slightly, and we're going to run it again. This time, instead of looking at an individual element, we're going to look at a compound and how we could do the same problem with a compound. So here we go. All right, so looking at pretty much the same problem, but I made one change. This time it says, what is the mass of 5 moles of sulfur dioxide? So I'm not just looking at an individual element this time in its elemental form. I'm looking at a compound, sulfur dioxide. We're going to have to do our nomenclature to figure out what is the formula of sulfur dioxide. It's got that Greek prefix in there, di, and that's going to help me out. Sulfur dioxide is going to be SO2. SO2 for sulfur dioxide. And then I've written little element blocks for sulfur and oxygen there. I'm going to start my problem the same way. I'm going to follow the question word. What is the mass? Mass. So I'll start it the same. If the question is asking me what is the mass, then I want to start with grams in the numerator. And then, just like last time, I'm going to change those grams to moles. This is the molar mass. The difference this time, I can't just use this number from the periodic table. I can't just put 32.06 here. The molar mass of sulfur dioxide is going to include all of the atoms in that molecule. So I'm going to have to add up 1 sulfur, which is about 32, and 2 oxygens, each one being about 16. So if I add all that up, I'm just doing that in my head real quick, I'm going to get about 64.06 grams per 1 mole of sulfur dioxide. How did I get this number? SO2. 1 sulfur plus 2 oxygens. 2 oxygens is going to be about 32. So 32 plus 32, it's just about 64 here. So that's how I got to that number. This is the mass for 1 mole, the molar mass for an individual mole. But I don't just have 1 mole, I've got 5 moles. So just like last time, I'll take this unit and I'll carry it up. I'll search for something that has moles in it, and it's that 5 moles. So my work is going to look pretty much the same here. The only difference was finding the molar mass. Finding this number took a little bit more effort than just finding sulfur. And I suppose the other step to this, we needed to know the nomenclature. We needed to know that sulfur dioxide is SO2. So you can see we're putting all our skills together here. If I were to do this math across, it looks like that would be 320.3. I can't reach over there. I think that's right. I might be off a little bit, but I think it is 320.3 grams of sulfur dioxide. And I figured that out by doing a little bit of nomenclature, by finding the molar mass, and then by doing a little bit of dimensional analysis and analyzing my story problem here. So this dimensional analysis, it's going to come into play. The nomenclature, it's going to come into play. We've got to have all these skills put together to be successful in these type of problems. Let's try, I think, one more. And I might make it a little bit harder, but we'll try one more, and then I think we can call it for today. Alright, so we're going to take a look at one more story problem here. And I've really kind of ramped up the difficulty on this one. I would say that if we were doing finals this year, this would be a finals level difficulty problem. So it's at that higher level, and we're going to do this one together. So taking a look at the board, what does my problem say? Well, it says, how many moles are in 52 grams of calcium carbonate? So, it's easy to get overwhelmed by a problem like this. There's a lot going on here, lots of different skills that we need to use. I'm going to show you my strategy, my way that I like to approach problems like this. My one thing you're familiar with, I always like to start with the question word. Especially if you are like mildly dyslexic like me, you might have trouble like picking out the important parts. Following the question word really helps me. So my question word is how. And then it says how many moles. Right away, I know that I need to start with moles in the numerator. So there's a pretty good start. I know where my starting point is for my dimensional analysis. Now, another piece of advice I have for you. When you see a story problem and it gives you the nomenclature for a chemical, like this one, calcium carbonate, I think it's a good idea to go ahead and get that formula right off the bat. What is the formula for calcium carbonate? You will probably have to look up carbonate if you don't have that one memorized. But calcium we should know. Calcium is Ca, and it's going to have a common oxidation state of +2. Carbonate is CO3, and it's going to have a common oxidation state of -2. +2 and -2, these cancel each other out. So my balanced formula is CaCO3. So calcium carbonate, this is CaCO3. If I really wanted to, and I'm gonna go ahead and do that. Let's just make it easier here. I could erase this, or I could make a note if this was a quiz or a test, that this is really CaCO3, calcium carbonate. So there's two things down. I've taken my nomenclature, I've changed it into a formula. I also followed my question word to get a start on the dimensional analysis. So where do we go from here? Let's take a look. Right now, I've got moles in the numerator. The only other information that the story problem gives me is that I have 52 grams of calcium carbonate. So I need to take these moles and I need to relate them to what I do know. And what I do know is the grams. Grams. So what I'm looking at here is moles per gram. This is actually still a molar mass. In the other problems, we saw the molar mass in units of grams per mole. We can invert those units. We can make it moles per gram instead. The difference is that the 1 is going to be in the numerator this time. I'm always going to have 1 mole for my molar mass because it's the mass of 1 mole. Down here, this is where I need to put the actual mass number, the molar mass. And remember that that comes from the formula. I've got 1 calcium, 1 carbon, and 3 oxygens. And I even gave us the element blocks here. You would look those up on your own periodic table at home or on a test quiz. So figuring out this molar mass real quick. If I've got 3 oxygens, that's just about 48. If I've got 1 carbon, that's 12. I'll call it 60. Added onto that 48. And then 60 plus about 40 is going to give me just about 100. So just about 100 grams. It looks like I've got some change there too. 100.09 grams. I picked this one because it's a nice easy one for me to do in my head here. Adds up to just about 100 grams. So 1 mole of calcium carbonate has a mass of 100 grams. But I don't have 100 grams. I've only got 52 grams. So how many moles is that? That's what I'm trying to figure out. My next step, I need to take this unit that's in the denominator, move it up to the numerator. Grams. I look for something in my story problem that has grams in it. It's going to be 52. 52 grams. These units cancel out, grams and grams. And then what I would do from here, 52 divided by 100.09. And that's going to give me my answer in moles. I don't have a calculator handy, but it's about half a mole, roughly half a mole. If I did 50 divided by 100, that's half. So it's actually a little bit more than half a mole, but approximately that much. So, just a quick recap of this problem, and then this is the last one that we're going to do today. First, I found some good starting points. I followed my question word, and I used that to set up my dimensional analysis, to at least start my dimensional analysis. I used to have some nomenclature here. It was spelled out. It said calcium carbonate. It's much easier to work with the formula, so I took that calcium carbonate and I made it into a balanced compound, CaCO3. Using the periodic table, I found the molar mass of this formula of calcium carbonate. I put that down here in the denominator. From there, I just did dimensional analysis. I made sure that my units canceled out. I used all the information in the story problem, and then I solved. Or I kind of partway solved. I cheated a little bit. But this is how we would want to approach a problem like this. The ones on your homework are actually not quite this hard yet. But definitely give that homework a shot. come to office hours if you feel like you need extra help, or if you have questions about e-learning, questions about anything. I'm here to help, and I get bored sitting on office hours by myself, so come say hi. That's it for today. We'll have another quiz tomorrow. I'll put out a new lab report tomorrow, and a new video lecture. Look forward to it.